Hello, folks, and welcome to Rational Science. We have another session today. What's different about this site? Well, what we do here is physics. And other people say they do physics, but they do mathemagics. What is mathemagics? Mathemagics is the movement of concepts. Okay, they move abstractions. Or like Mr. Bourne said once in the 1920, I think 1960s, sorry, he said that physics was becoming more abstract. But it turns out that abstraction or abstract is the opposite of physical. So physics has to do with the physical, and abstract has to do with whatever the opposite of physical is. And so you figure it out. What mathematical physics does is abstractions. And here we do real physics, the only site on the internet, really. We model everything with physical objects. Now, uh, people will say, well, that sounds like classical physics. And yeah, you could say that. I mean, classical physics considered particles to be real corpuscles, like dusts of sand or, any particle, any corpuscle, what you would think is a little ball of something, right? And that faded away with quantum mechanics. A lot of people are not aware of that. They ask questions as if they hear the word particle and they think that particle refers to, what everybody understands for the word particle. It's a little speck of dust or a grain of sand. That's not what a particle is anymore. You say, well, what is a particle? Well, a particle is a wave function. And what is a wave function? Well, you see, the wave function is an equation. And so, what is a particle? Well, the wave function collapses and turns into a dot. And that's what they call a particle, an equation that collapses and turns into a dot. So you can see that we're a little farther away from physics now. There are no physical interpretations, which is what the common man out there wants to understand, because he doesn't understand all that math. He wants to understand what you get out of it. What's the bottom line? And the bottom line is, you would think that they have, the mathematicians, that they have an explanation for how this universe works. How does gravity work? How does magnetism work? And instead they say, and the wave function collapsed. And you say, oh, I missed that. This is over my head. What did you mean by that? Well, you got to take math, university math to really, you know, understand what we're saying. There are no physical interpretations emanating out of mathematical physics. That's the bottom line. Okay. And so, when people like in Quora, they ask questions, they want to know how the universe works. The common man wants to know that. That's all he wants to know. And these people give him the runaround. They say, look, you got to have this equation. This equation proves this. And what they give them is a description and an irrational explanation for that equation, because they can only provide irrational explanations if they model their theory with particles. That's the whole issue. And until you understand that, you have no idea what science is about today, what physics, so-called physics, is about today. Anyways, we start our first half of our lecture with subject matter related to extinction, the extinction of man. What are we talking about? Well, we're talking about, I'm saying that in this channel, right? We say that we are the last humans on Earth. last generation of humans on Earth, whatever generation means to you. We got very little time to live. We're not going to live decades. We're not going to live centuries. We're about to die as a species. We're going to become extinct together with all the other mammals. This is the end of man. And people have say, Bill, you know, you're a little pessimistic. No, I drink beer and wine. I can't be pessimistic. No, I'm realistic. That's what it's called. Okay. I'm urging you to get your feet on the ground. And maybe this is not a good idea. If you want to live life, maybe you should forget about what I say in this channel. It's not a very popular channel in that sense. You don't want to believe in the theory. You want to believe that maybe you got 100 years in front of you. But, you know, one thing is having a false sense of security, and another one is reality. And so, what I'm saying, I'm not pessimistic, I'm realistic. Okay? And some people would rather listen and learn what the theory is about, and other people dismiss it altogether and say, no, 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 I don't want to even hear it. Okay, your choice, you know, that's fine, no problem with me. Anyways, here we have some news. It's got to do with this bug called Omicron. What the hell is Omicron? Well, it's a variant of COVID. You know, we had the alpha, beta, zeta, whatever, delta, and now we have the Omicron. And I'm sure there's going to be a couple more. And that means we have all these variants, okay? And the new one is Omicron, and now they're going to shut down the world apparently in some place, especially here in Europe. I'm in Germany. I think they're going to be shutting down Europe during the winter. And what I mean by that is, you know, international travel is going to be a problem, and hotels is going to be a problem. Restaurants are going to be a problem. Anything that has to do with leisure, like physical leisure, where you go with your personal body, you know, is going to be switched off. Okay. And I don't know if that's a good idea. Okay. But anyways, let's get on with the headline here. It says the following. It says UK economy slows in third quarter before arrival of Omicron. In other words, before the Omicron, already the UK economy was apparently having some problems. But that's not why I put this article here. I put it because of what it says in you know, I just pulled out these snippets out of there. It says, in output terms, the largest contributors to the increase in quarter three were what? Hospitality, arts, entertainment, and recreation. And in contrast, production and what? Construction both fell. And also they say motor vehicles fell for the third quarter consecutive. And what is this telling us? That means the whole global economy, really, because this is England, right, in the UK or United Kingdom. But the issue here is that all these advanced nations have this exactly the same problem. So what we see here is really a microcosm of all of Europe, all of the Western world, perhaps all of the planet. Okay, you have countries in South America. I was talking about Argentina the other day. I'm sure countries in Africa have similar problems. What are they all experiencing? Well, they're all experiencing the same exact thing, no matter where you go. And that is that everybody is developing those uh, non productive segments of the economy. And what's falling as a percentage of GDP in every country on the planet is the production, the stuff that produces something tangible. And it turns out that the tangible stuff is what creates growth. And I keep giving you that scenario. You and God are next to each other, you know, You're both embracing yourself. You're looking down on the planet down below, right? You're up there with God, right? You're seeing the whole planet. What do you see? Well, you see what's being produced, what's physical. You see the houses, you see the highways, you see the bridges, you see the ships, you see the cars, you see the airplane, you see the tangible stuff, you see the fields of corn, the fields of wheat. That's what you see. That's real. That's growth. And what's expanding now is what? Hospitality, arts, entertainment, and recreation. What the hell is that? Well, that's all this abstract stuff. In fact, what all this really is internet. What's expanding is the internet, even at the expense of manual services such as barbering or landscaping. What's expanding is the internet. So we're all moving into the internet. And the question is that I ask foolishly, people don't believe, don't even understand sometimes. Can we run a world on leisure? On just abstractions? And all I can say is food for thought. Okay? Can the world just be run on abstractions and commercials that, ads that they put on the internet to stimulate the abstractions? That's what we have today. That's the world of today. So yeah, the UK economy in a way is giving you an idea of what's happening in the world and why we're approaching a point where it's all leisure, it's all vacation, it's all fun, entertainment. Can we run the world on entertainment? Some people will say that you can. And I take the opposite view. My 5 cents worth. Okay, anyways, I'm going to tell you a little story today. And it's got to do with probably some of you heard of Hans Christian Andersen. And other people even have never heard of this story. So I have to go through the story first. Okay, it's got to do with this Omicron thing. Okay, and it starts like this. It says that there was a king, an emperor, and he heard about these two weavers that could weave the best cloth, the best suit, the best robe for a king that you could imagine. And so he wanted to meet these two fellows, okay? And so here's the king meeting the two fellows, okay? And they say, look, we can make a robe for you that will knock you out of your socks. And the king said, okay, and I kind of like that challenge. Okay, I'll hire you. So they hired him, the two fellows there. They started weaving, and they started weaving inexistent, invisible, intangible threads. And I know people say, hey, Bill, that's your thread there. It's invisible, intangible. Yeah. Yeah, don't tell me what I know already, okay? So these two weavers, they started weaving intangible threads, and they went through the motions. In fact, they had no threads. They just went through the motions of weaving thread and making this robe for the king. Obviously, an invisible, intangible robe, because there was nothing there to begin with. Okay, so the king, heard that these guys were working there, told one of his ministers, one of his dukes, his counts, he said, go out there and see what they're doing. I want to see tell me what the robe looks like, more or less, what it's starting to look like, because I'm going to be wearing it in public. I want to know what it looks like. And so one of the guys comes over here, and the pitch that these two weavers were saying is that anyone who could not see the robe was not deserving of their position. In other words, here we had Electromagnetic threads. Yeah, here we have a situation where, if you couldn't see the robe, if you couldn't see what they made, their argument was that anyone who could not see it was not deserving of their position as a minister, as a right hand man of the king, of the emperor. So this guy comes over and he doesn't see anything, and so he wonders, what am I going to tell the king? He's a little worried because he doesn't see anything, but he says, I can't let him know that I don't see anything because the king knows already, has been lectured, has been led to believe that anyone who can't see the robe is not deserving of his position, of his job. So he says, oh, it looks so wonderful. What a beautiful robe. Okay. And then the king sends a second fellow, and he looks at it and he says, same thing. He looks at it, he says, I don't see anything. Could be that I'm not deserving of my position. He says, it's beautiful, it's exquisite. So he starts believing in the robe. And the king sends another messenger, another fellow, his right hand man, maybe even his son, and he says, what do you see there? What does it look like? Is it good? Your other two ministers said it looks great. And the guy doesn't see anything, but he has to, play along. He says, oh, it's just absolutely gorgeous. And so they all just fell in for the ruse. They said, yeah, the robe is absolutely exquisite. It's great. It's lovely. And now it was finally the king's turn. The emperor has to come over and he has to look at it, and he also wonders, how beautiful this robe is that they prepared for him. And he goes in there and he says, okay, yeah, I've come here to see the robe. Want to see what it looks like. And when he looks, he can't see anything. And so now we have a problem because, the other fellows behind him say, well, nobody can see anything, but everybody has to say that they did. And the king himself, he says, am I not deserving of my own job? No, of course not. So he has to fall in line as well. And he says, oh, it's ravishing. It's the greatest thing that I've ever saw. Okay. And so, the story as the story goes, the king ends up parading naked around the city. Okay. And it's just a little boy, I think his name is Bill Gaty, who says, the emperor is nude. He's got nothing on. And everybody just says, no, it's a great robe. I love it, And the guy's parading naked around the city. So that's how the story goes. I think it's a great analogy for what happens in relativity and mathematical physics and quantum and string theory. And here's the relativity version of this. Okay, here you have the emperor's tail, and they say it's space-time. And people say, oh, space-time looks so great, so beautiful. What are all those dots there? Oh, those are the black holes. And what's all that fuzziness that I see around the galaxy? Oh, that's dark matter. And yeah, you can't see or taste or touch or anything with those. And the reason is very simple. These are abstract concepts. Black hole is a singularity. A space-time is what? Space and time is time a physical object. And dark matter is just a bunch of particles, just a concept there. And so, yeah, these are concepts. That's the problem, okay, with this so-called theory of relativity. And then you have, the quantum, also the quantum fellows, the people, they have their own tail. It looks more or less like this. It's the wave function tail. And again, people say, well, what are you staring at? Well, we're staring at a wave. And what's a wave? Well, it's this function that has, fields, two fields, and what flows in one direction is energy. And all these are concepts, and obviously you can't see them, but you have to go through the motions of believing that they exist and that you can see them. Okay, and here we have Richard Feynman. He says he's going bongo over this. Yeah, no kidding. Okay, yeah, you got to go bongo over this nonsense of talking about abstractions and turning them into physical objects. And you say, Bill, what does this have to do with Omicron? Well, we have the same situation with Omicron, with this virus, okay? And all I can show you is the following, okay? Here's the two weavers, and they say, here's the Omicron bug, the virus. Do you believe in it? Can you see it? Can you touch it? Are you aware of it? Do you believe in the theory, or do you accept the theory? Do you understand the theory? Okay, that's the issue here. And yeah, here you have the COVID flowchart to get down to the bottom of this issue. There's people out there who will tell you that this Omicron, not even Omicron, the COVID, is a hoax. It's not real. It's something run by the politicians, the Illuminati, etc., the New World Order people, the people who rule the world, the filthy rich, And this is a hoax. You don't have to believe this COVID thing. Don't get the shot. It's probably going to do more damage to you than anything that you ever thought about. And so I created this COVID flow chart to get to the bottom of this. I mean, if you're really honest with yourself, if you're objective and you really want to get to the bottom of it, you might want to follow at least some of these steps in the flow chart. Okay? And we bring back to life Mr. Alhazen, and he said, whenever you analyze a theory, the first thing you have to do, especially with those theories you believe in, is attack your theories with the utmost vehemence. Become an enemy of your own theories. Okay? And so if you can attack your own theory with everything you've got, with everything you can think of, and you come out on top after that, then at least you know that you can defend your theory from anyone who can attack it, because you have more or less, resolved all the arguments. Okay? But if you just have a belief and say, well, I don't believe in the COVID, I don't believe that this is real, I think it's a hoax. Well, maybe you have an unsubstantiated belief because you have no backing for your theory. Okay, so what I'm suggesting is you follow the flow chart. It's, I think, a minimum required of anyone who really wants to be honest and get to the bottom of, his beliefs. If you're going to hold a belief of a theory, right, of an explanation, I think you should more or less follow this flow chart. Okay, recommendation. Okay, and so the first question is there an object called a virus? Some people don't even believe that there are viruses out there. So obviously you cannot talk to them about an Omicron or a COVID virus, because they don't even believe that there are viruses out there. They don't even know what these researchers or doctors or health workers are talking about. What do you mean? What's this virus thingy that you're talking about? Okay, so let's get that one settled. Okay, this is what you see under the scanning electron microscope. Now, I was certified on a scanning electron microscope. I knew how to run it. I would see things not of this nature, I would see semiconductor chips, very tiny chips, transistors, that kind of thing. But I understand what a what one of these SEMs is, scanning electron microscope. There is a more powerful one known as the atomic force microscope. And this is what they see under the scope, under these high powered scopes. You know, here you see all these different types of viruses. Now, you don't want to call them virus, you want to call them X. I don't care. There's something there, okay? And so for you to say that this is not there, it just shows ignorance. That's all it is. Because this is like the flat earther saying that the earth is flat. You know, if the earth is round, spherical, and you say that it's flat or that black is white, you know, that on is off, well, you're just being either ignorant, foolish. You know, you just look up the words. Now you have to look at this and say you got to give these things a name. They see these things under the scope. Okay, you don't have to believe in what they are. You know, you may have all the theories you want, but you have to recognize that these things are things that they see under the scope, under the scanning electron microscope. Okay? So whatever name you give these thingies, I don't care. They call them viruses. You can't say that the virus does not exist. Okay, that's my first argument. So if you say no, that you don't believe in viruses, well, you go to jail and you don't collect 200. Okay, that's my take on that. Now, do the viruses cause disease? And that's a big if. Not everybody agrees. And there I can't tell you much because, you know, I'm not in that field. There's a field I'm not very much interested in. I've said that in the past, okay? But I'm just saying that this is those people who are interested in the subject, these are the questions you should ask yourself and go do the research. You know, make sure that you understand what you're rooting for, okay? If you believe that viruses don't exist, you have a problem because there is something under the scope. Now, do you think those little balls that you see in there, they cause disease? That's a second question, okay? And here's one fellow, and he pointed me to a video, and he says, look at this video, Bill. Okay, so I watched a little bit. I haven't watched all of it because I got the sense of it in the first, I think the video ran like 45 minutes. I saw only like 35 minutes, and there were 2 more videos of this stuff. So I didn't go through all of it. But this was the overall picture from the first half hour, okay? Fellow, this Dr. Trent, he says there's lots of diseases that are caused by environmental factors, such as pollution, sewers, hygiene, etc. Okay? Vaccines are developed in rodents and monkeys, but these animals carry other viruses that are later passed on to you with a vaccine. You know, sometimes the manufacturing process is not careful enough. Some of these other viruses that, you know, belong to these monkeys, these rodents, they're passed on to you with a vaccine. And they say, well, this is the vaccine, this is the COVID vaccine. We give you the shot and you get, you know, the other viruses that you never bargained for. Could happen. Okay? I can at least understand what he's saying. I can imagine that it could happen. It is another notion that this doctor was saying is it's not wise to alert the public about all that's involved in vaccine R&D and manufacturing because it might create a panic. In other words, the common man does not always understand what's going on in the research centers, and he might imagine more than what's there and imagine the worst. And so governments are careful with the information that reaches the public, and the establishment, the health establishment, sometimes says, don't tell this to the public. Because if you tell the public, they don't really understand. They're going to go into panic. They're not going to want the vaccine. and they're just going to be doing more damage to themselves than what it's worth. The vaccine is good, but these people, are going to interpret it in the wrong way, so we might as well not give them the information. And other doctors who are aware of the information says, they're hiding the information because they know it's going to scare the public. Why? Because the public is going to be aware that there are problems. And so it's damned if you do and damned if you don't situation. And that's what this doctor was saying. One of the arguments he raised, he says that the establishment doesn't always want to give information to the public. Okay? And then another issue is critics are systematically silenced on or given career redirectioning. Yeah, there were people like Mrs. Eddy, if you look her up, Eddy, and she criticized a lot of these investigations, these R&Ds, these researches, and the conclusion they drew from them. And she was given new assignments, saying, we need you over here. So they pulled her out and put her in another place where she caused less of a trouble. And there's a lot of whistleblowers within the health industries, not a lot, but there's always a percentage of them that say, I think these people are lying. I think these people are not doing the right thing. They're not telling the public what's really going on. And you know what the health officials say, look, you're in the way, because if you tell that to the public, you're going to create this bigger monster than what we're trying to do here. And so they move them away, or they try to silence them, etc. And more or less what's happening in the mathematical physics establishment, where anyone who opposes that is considered a dissident, meaning that you're considered a nerd. You're considered a person who's not in tune with the mathematical establishment. Okay, and so they move you aside. They don't even pay attention to you. They censor you because you're opposing the establishment. I know a little bit about that because I've been there 20 years, and so I can sympathize with them, with these people who oppose the establishment. Now, whether you do more damage in the health industry than you do in the mathematical establishment, where they're dealing with theories, abstract theories of how this universe works, I think those two situations are different. Okay, but yeah, I can understand that some people on the inside see things that they don't like and that they think are anti or not in the public interest, and so they want to whistleblow. They want to, tattletale on what the establishment is doing. And one of them was, again, my mom. She worked in a hospital, and she worked later on with a dentist, and she saw things that she didn't like at all. A lot of commercialism, the drug peddler coming over to the doctor saying, sell this drug for me and you'll get a 10% bonus and that kind of thing. And so she saw a lot of things she didn't like. And so, yeah, I can understand a little bit about this. It's human nature. That's how we all are. Okay, another one, case histories of people who got this or that vaccine and succumbed to the disease anyways. And then you have the vaccines such as polio, according to this, all caused cancer. So, you have all this stuff and you listen to a guy like him, and the question is, should you believe him or should you take what he says as a grain of, with a grain of salt? What should you do? Unless you're really in the business, it's kind of like weird. What should you do? What should you believe? And you have all this information out there, and you have two sides to the question. You have the establishment, and if you don't like the establishment, you say, oh, they're lying. You may be choosing the wrong side. I can't tell you. All I can say is that there's a lot of politics involved, a lot of interests involved, and that gets in the way of the truth, okay, whatever the truth is. Okay, um, here you have how the virus really works. Okay, it makes copies of itself, right? And inside the cell, and then pollutes other cells. This is the theory right behind it. Do you believe in this theory? Well, again, it depends on you if you're going to believe this or not. And then if you do believe that this is what happens, the question is whether what you're going to do about it. How do you think this should be cured? Assuming you believe that viruses exist, viruses cause disease, there is this virus called COVID, which is different than all the others. Okay. And then, assuming you accept all that, right? Are you going to take that next step and ask the question, what should we do about it? And these people, the health experts, they've decided that the way to combat it is through chemically. In other words, you create what is known as a vaccine, and they're going to inject it to you. It's going to create antibodies so that if the virus hits you, you are in contact with the virus and it enters your body and it tries to attack your cells. Well, then these antibodies work to help prevent that. They attack this virus. Now, the virus is not a living entity, and you have a lot of doctors out there that don't even understand that, and that's because they never define what life is, what a living entity is. Biology to this day has not done that across the planet. No university on the planet, no biologist on the planet has defined the word life. They say, well, that which reproduces, sleeps, takes a dump every morning. They talk about what the thing does, and they try to define it based on what a thing does. And actually, it is what a thing does, but there's only one common factor, and that's that any living entity moves against gravity. Actually, it moves against the path of least resistance. That's the formal definition we propose. But the primary issue is gravity. If you can move against gravity, you're not a rock. You're not an inert thing. Okay? So that's the bottom line. And the question is, a virus is just a molecule. It's a little round ball-like molecule. Not always, in the case of the rabies virus, it's like a cylinder, right? There are different types of viruses. But the point is, it's an inert molecule, a very complex molecule built with proteins, etc. And what it does is once it enters the cell, inside the cell, it uses the cell material, living material, it eats it up from the inside and makes copies of itself that later on sprout and infect other cells and do the same thing to those cells. That's the theory. Whether you believe it or not, that is the theory, okay? And so the question is, do you think that's what this COVID thing does? And if you decide that it does, that's what the theory is, and you think it's a good theory, unless someone produces something different, right, out there, well, then you have to conclude that you got to attack it somehow. You have to address it somehow. And the way these health professionals have decided that they're going to attack it is through chemistry. They're going to create a vaccine which creates antibodies within your body. That's essentially a chemical process. And if the you come in contact with a bug, then you have defenses against it. They will attack that virus, meaning they're going to break the molecule up, or they're going to render it inert or whatever. Okay, they're going to neutralize it. That's the theory. Okay. Okay. So, I'm just saying that's the checklist that any rational person, anyone who wants to reach to the bottom of the issue, wants to be objective about it, you should ask those questions to yourself. Do the research on those topics at least. Maybe you've got some better questions, no problem. But the issue is you have to attack your own beliefs. Then you know you're solid in your beliefs. But to say, well, I don't think there's any bug out there. I don't think that there is such a thing as COVID or that it causes disease. I think this is just a thing from the ruling classes. So far, you have said nothing to a rational individual. Okay, it's not a question of belief. It's a question of do your research as much as possible, and find out whether you are solid, that you can present an argument for each one of these questions. Are there viruses? Yes or no? Is a virus, does a virus cause disease? Is there such a thing as a COVID virus? And if you say yes to all of those, then the question is, what should we do about it? Okay, moving on here. Here we have another situation. We have the International Business Times that says, the World Health Organization sees unprecedented Omicron spread, probably in most countries. And the EU is to decide on new COVID jab as Omicron rages. And there you have the coffins in Germany. One picture that they show, like saying, beware, this thing is out there, it's going to kill you. And so this is a little bit of fear mongering. Okay, you see all these cases in 1 week in the entire planet. Okay, there. And so the question is, here you have another side of that story that came out the other day that I pointed out to. It says the Omicron variant, considerable protection against severe disease is maintained. They're saying that the Omicron is out there, right? But you don't have to worry too much about it if you have at least 2 shots already, 2 jabs, because it already protects you more or less against this Omicron as far as they can tell. And at the bottom you say, Omicron, no need for a variant-specific booster at this time. Okay, so why are they raising so much hell about this Omicron if the 2 vax that I got, I got on my shoulder, and I think it was in this one, I can't remember anymore. The 2 shots that I got apparently defend me or protect me against the Omicron. There's a new variant called the Omicron. Apparently, other than 2 or 3 modifications, mutations, it's got like 10 mutations over the Delta, or at least to the original COVID. I can't remember which one, but the point is there's more variations in the new strain known as Omicron. Okay, great. I don't care. I mean, do the 2 vaccines that I got protect me against the Omicron? Yes or no? It's a black or white issue. And these people are saying, yes, they do. That apparently it, softens the blow or whatever. So why are we developing a new vaccine against the Omicron? Why are we closing the entire planet again? Apparently we're starting for this new winter session, closing up all these places, restaurants, hotels, tourism, etc. Why are we closing everything down if the Omicron is just a variant of the Delta or of the COVID, original COVID, the Alpha or whatever it's called, and whatever vaccine you have in you is sufficient to protect you against the Omicron? Why are we raising a panic again in the world of economics because there's a health issue? And like I covered last time, right now Russia showed 16 cases, Cuba showed 4, and other countries showed, very few. We're talking about 8 billion people being locked down because 4 people have a disease, which apparently hasn't killed them yet. There was one case apparently in London, in England, where one person died. Should we stop the entire planet because one person died and some people, a handful, we're talking about 10, 20 people, have the new Omicron variant and they get maybe sick, or maybe they don't even get sick, they didn't even know they had it? Should we shut down the global economy because of this? This is where you have to stop and think, is this real or not? Is there something else going on? Is this politics? You know, okay, changing the subject. That was food for thought. Fellow says, is this normal? I said, is this normal? And the fellow says, please define normal, Bill. Define it first. And what am I talking about? Well, I was talking about these people who are born with XY and they change their sex. They continue to be XY, but they want to be XX, double X, okay? We have mispronouns. His name was like Tommy, and they called her Sally at the Miss Universe contest, representative from Nevada. We had Victoria's Secret representative, and the secret was that she was a he. And we have these fellows who are, XYs fighting XXs, and people, especially women, who are fighting in those categories are a little upset because they say these guys, during their puberty, they were XYs, they developed these muscles based on, testosterone, and now they inject estrogen in themselves to grow boobs and whatever. Are these males or females? Should they fight against females? And so we have all this situation these days, and it's kind of weird. So this fellow says, Bill, define normal. If you say that, is this normal? I mean, what do you mean by that? And all I can tell you is I have defined the term in the past. Okay, I have defined the term, and so let me go over the word normal again. Okay, and this is the analogy so that you understand what I mean by normal in this context. Okay, and you go to the river and you see some swans, and they're all white. And suddenly you see a black swan go by. You say, whoa, I thought all swans were white. And here's this black swan, completely black swan. Oh, this is not normal. Well, is it? Well, it turns out you do a census of all the swans in the world, and you find out that 10% of them are black. Nothing racial here, it's just that it's a fact, okay? 10% of the swans in the world are black. So it turns out that if you see a black swan among, 9 swans, well, it's normal. It's normal because 10% of the global swans are black. That's what you call normal. But what happens when you do a study and you say, okay, in the year 1990, there were 10% of the global swans that were black. In the year 2000, it was 11%. In the year 2010, it was 15%. In the year 2020, it was 20% of the swans were black. Well, now we have a problem. Not really a problem. What we have is we have a phenomenon we have to explain. Why are the number of black swans increasing as a percentage of the global population? Are all swans becoming black? And so you have to answer that question. This is no longer normal. Normal now is out the door because you're saying something is happening and it needs to be explained. Now, in the case of the color of swans, it may not make much of a difference. But in the case of homosexuality, it might make a little bit of difference. I mean, if the number of homosexuals are increasing as a percentage of the population year by year by year, not only is it not normal, but we got a bigger problem. This is not a cosmetic problem where the color of our skin is changing. We have a problem where, we have people who are not going to be reproducing because they're not interested in the opposite sex with which they're going to be creating, another human being. So this has to do with population increase, right? With a rate of population growth. So now we have to address this issue. Is this normal? The fact that not only people are converting to the opposite sex, but that there are ever more of these people converting to the opposite sex. And in 1973, you had the American Psychiatry Association. Later on, 3 years later, we had the Psychology Association, American Psychology Association, doing the same thing. They declared that homosexuality was normal. In other words, they took it out of the list of mental problems. Okay? Later on, the World Health Organization did the same thing, following their cue. And the question is, why did they do that? Was it because they decided that homosexuality was normal? Quotations. No, the problem was that, in the last few years prior to 1973, hundreds and thousands of homosexuals invaded the Psychiatry Association, the psychiatrists, the shrinks, and they said, "Doctor, cure me. I got a problem." "Yeah, what's your problem?" "Well, I'm homosexual." And what was the doctor going to give them? A pill to cure them? And when they had so many people come to them, they said, "Look, we got to do something about this." And they finally decided, hey, we got the solution. Let's say they have no problem, period. We're done. We have no pill to give them, nothing that will overcome their homosexuality. So let's accept them. Let's just say that it's no longer a mental disorder. So they took it out of the list of mental disorders and they say, you guys are free. You guys are okay. As long as you don't have a problem with yourself, you're okay. That was the decision taken by the Psychiatric Association. But why did they do that? Because they had more and more and more and more cases. They had to turn it into something normal because they said, well, it can't be that 10, 12, 15, 20% of the population is homosexual. We'll just call it normal. What the idea was, and the way this thing developed, was that historically, they had silenced homosexuality, saying, if you're a homosexual, you're mistreated. The law goes against you. We punish you. And so these people remain in the dark. And now that we have a little more, flexibility in the law, these people could come out of the closet, and all we're doing is just seeing more cases because of the law, not because of something that happens in the biological world. They were always there. Now they just came out of the closet. That was the overall notion. But was that the case? Is it that these people were always, 10, 15, 20% of the population, or is it that the numbers have increased over the last few years? And that's for you to judge, okay? So until that question is answered, the Psychiatry Association of the United States really never answered the question. They just said, we're going to consider it normal because we've seen all these cases. And the question is, if this was a private issue between the patient and the doctor, the psychiatrist, the shrink, then we had an increase in people coming out of the wombs of women which had this we'll call it a mental disorder until then, right? They had a mental problem. That's why they came to see the doctor. They say, I got a problem, doc. I like men. I'm a man and I like men. So they had a problem. They go to see the doctor, the shrink, the numbers increase, and the doctors, instead of saying, oh, this is not normal, instead of concluding that more homosexuals are coming out of the wombs of females, they decided, oh, this is normal. They've always been there, and the only change is that now they're coming out of the closet. It's up for you to decide, okay? That's the issue there. And so, yeah, what I'm saying is normal is if it's always remains the same percentage, you can say that's normal. If there's an increment, then you have to explain it. You can't say it's normal. No. And especially in this case, because remember, the purpose of sex is not like what the homosexual lobby wants to spread out there, that it's for fun. Mother Nature invented sex not for pleasure. If you get pleasure out of it, hey, more power to you, no problem. And that's good. But the issue here is that sex was invented for exclusively and only for procreation. Two homosexuals, whether two females, two males, they cannot reproduce. They have to go to the sperm bank or get hire a womb somewhere. That's the only way. But two of the same sex cannot reproduce. Therefore, we have a problem because it's a violation of nature, what Mother Nature intended. It has nothing to do with pleasure. It has to do with procreation, and two homosexuals cannot reproduce, no matter how you twist and turn it. You got to do it artificially. You got to go get a third party, the donor of the sperm or the donor of the womb, in order to have a baby. And of course, the question is whether this trend of people becoming homosexuals or changing their sexes is normal. And if we have more and more of these every day, is this normal? What is it leading to? And under the theory of extinction, yeah, it goes against extinction because, it's part of the extinction process. Why? Because you can imagine that we're going to be producing fewer children if we're becoming more and more, if a bigger percentage of the population is becoming more homosexual. Okay, so that's the theory. That's the notion. Okay, moving on here. We have a fellow says, no life can travel interstellar. It is forbidden by Father Universe. That's my statement. And a fellow says, don't give your opinions. Give us your theory. This is where you do rational science, remember? Yeah, and I have explained that. In fact, have a video. You can look it up. It's called the Pioneering Anomaly, and it's in playlist under Gravity, and it'll explain my theory. But in a nutshell, it essentially is, every atom in your body, okay, is bound to every atom in the universe. Let me repeat that because maybe that hasn't sunk. An atom is something we can't even see. In case of the hydrogen atom, you're talking about 3 angstroms. Something, invisible. You can't even see it under the microscope. Okay, you can't see it under the SEM. You can't see it under a scanning electron microscope. You cannot see a hydrogen atom. That's how small this thing is. Okay, and one of these guys is bound to every atom in the universe. I hope that sinks in. I mean, in the galaxy, in our galaxy, we don't even know how many stars there are. Billions of stars. Each one with a solar system like ours, maybe, with planets rolling around. And there are billions of galaxies. So we're talking about, let's bring Carl Sagan back in, billions and billions and billions. Okay? We're talking about a big number. So one atom is connected to every atom in the universe. When one atom, I mean, even in your room, you have billions of atoms. Okay, so alone, just one atom in your body is connected to billions of atoms in your room, let alone billions of atoms in the solar system, billions of atoms in the galaxy, billions of atoms in all the galaxies. I hope that sinks in. Okay, it's a big number. And so people say, "Whoa, such a big number." Yeah, and so if an atom is bound to every atom in the universe, okay, you can see what implications that has. Okay, an atom is made of the threads coming from every atom in the universe. So yeah, what can I say? If you're going to be traveling out of the solar system like this fellow wonders, right? Your atom, every atom in your body is connected to every atom in the sun. Let's just talk about the sun. Obviously, the Earth, Jupiter, Mars, the whole works. Let's just talk about the sun. Every atom in your body is tied to every atom in the sun. How many atoms are there in the sun? Have you counted them? Gazillions. Every atom in your body is bound to every atom in the sun by gazillions of ropes. I hope that sinks in. Maybe it doesn't. People, it's a number so big that it just breaks your mind. But that's not the point. The point is the following: you run away from the sun, which is the biggest mass in the solar system, right? The biggest mass is the sun. It's got all these atoms, more atoms than all the planets put together. Jupiter, Neptune, the whole works. So you're running away from this, going to Alpha Centauri, the nearest star, which is just barely a petty 4.3 light years away. Meaning if you travel at the speed of light, you get there in 4.3 years. 300,000 kilometers per second, you get there in 4.3 years. So it's far away from a human perspective, from our everyday perspective. So you're running away from the sun. The farther away you get, all those ropes, what happens to them? Well, they kind of, move into a single coaxial. They kind of, come together the farther away you are from the sun. And then there's this region, this long region, until you get to Alpha Centauri, Proxima being the first star, right? And until you get there, you get this long region, 4.3 light years. That's a measure of distance, in which, essentially you have a straight coaxial. So there's no gravity. You don't have Newtonian gravity. Newtonian gravity is only what I call the bird speak. The region coming out of the solar system where the ropes are still in a triangular manner, kind of, coming into what I call the linear regime, okay? So during that period that you approach the linear regime, yeah, you have the inverse square of the distance function. But when you get to the linear regime, there is no gravity. Now you go straight ahead. You drift to the other star with whatever, impetus, whatever impulse you had from the solar system, from your boosters or whatever. So, yeah, you can't travel to the nearest star because you'll never make it, not alive. Okay? And so, well, you got to watch the video to get the feel for it. But that's in a nutshell what the video says. Moving on here, next issue. Okay, it says, fellow says, it is an imperative for science to fully understand consciousness. I'm going to roll over my tomb anyone who says consciousness. I hate the word. I don't want that word in science at all. Anyone who says consciousness is talking about religion, especially Eastern religions. So, get that out of my sight. Anyways, the final frontier, absolutely not, has nothing to do with anything. We know that it can't be just nothing. Aha. When we so-called die, that can just happen because of the, can't just happen because of the first law of thermodynamics. Energy will only alter. So he's suggesting that this consciousness is energy. And it turns out energy is a concept. Okay, so what have we learned? That we have this concept called consciousness, but he thinks it's a thing. It's not nothing, meaning it's something, meaning it's an object under the definition of object. Of course, anyone who has a different version of the word object is welcome to put it forth. Okay. Anyways, he says consciousness is not nothing, meaning it's something, meaning it's an object, it's a thing, and that he reinforces that by saying that it's energy, meaning that it's, under the mathematical physics notion, it's something. We're not talking about nothing, we're talking about a thing, an object, a body. Okay, that's what they're saying. The Leibniz experiment not only put free will into question, it demonstrates consciousness is non-local to the body, meaning this thing stands out parallel to the body. We have this consciousness, out here. Okay, our consciousness can affect the outcome of experiments. So not only the consciousness leaves your body, it's in your body, it has a separate existence outside the body, but now it's going to affect the experiment. This energy flows, the spirit flows, and it's going to affect your experiment. What experiment? Well, especially the double slit experiment. Some people believe in this stuff. It's unbelievable that they truly believe that to this day. I mean, we're in the 21st century, and these people are in the days of the 4th century, where the monastic era was in its heyday, and they believe that in spirits, in souls, in these phantoms, these things that go to heaven or hell, that they survive the body. Some people believe that the body weighs more when it's alive, dying, and that when it's dead, it's like it weighs less. And they say it's because this spirit, this energy, this ghost leaves the body. So what are they saying? Are they saying that there's a spirit that has shape, maybe made out of atoms, some kind of holy atoms, because it has weight? It's a body that has, I hate to say it, but shape. It's an object. It's a thing that comes out of the body. The real body, the one made of meat, of flesh. Is there such a thing? These people believe in this? 21st century. They believe consciousness comes out of the body and is a thing. No, obviously, rational people, just scratch their heads. They say, well, what is this guy talking about? No, the so-called spirit, soul, consciousness, mind, thought, dream, nightmare, whatever you want to call it, I don't care, is a verb. There's no physical object called consciousness that you can bring to me and put on the table, because the definition of a thing is that which has shape. So no, this guy said it's nothing. No, not nothing, he said. No, it's nothing. It's not nothing, meaning a thing. It's nothing. There's no such thing as consciousness. Thing is that which has shape. Consciousness doesn't have shape. Consciousness it's worse. It's a verb. It's a concept. And so for people to turn this concept, this thingy like they did in the traditional religions, turning into the soul, the spirit that goes to heaven or to hell, depending on how nice it was, if it's black or white. It's nonsense. Obviously, it's nonsense to a rational individual. But irrational people believe in this stuff. And regarding the slit experiment, that's got a very simple solution under rationality. You don't have to believe it, but we do have an explanation. Here it is. That's the explanation for, the slit experiment. What are we saying? We're saying that if you shine a light through monochromatic light, right? If you shine monochromatic light through two slits, very narrow, etc., you're going to get what you see on the right. You're going to see a spreading out of the ropes, okay, that are binding the two of the atoms. This is just an example, right? Just a sample microcosm of what's happening. We're taking two atoms on the sides of the needle, right? And we're saying that they're connected to all of the atoms on the screen. And so you have this situation where, they're offset by so much of a link. And because of this tiny offset, you create these fringes, these different patterns. So it's very simple under the rope model. It's only under mathematical physics where they have big problems with this. They can't explain it. And that's because they try to do it with math and with particles. That's the whole problem. We don't need math. We don't need particles. Particles cannot explain this phenomenon. You have to explain it with something which is elongated and binds the atoms of the needle to the atoms of the screen. And why we use a needle? Very simple. We use a needle because, with a double slit, the notion that the particle folks have is that the particles bounce against the window sills of the slits. So they bounce and come in. That's the notion. But if you put a needle there, there's nothing to bounce against. There's no frame. There's no window sill for the photons to bounce. If you put a needle, we still can produce the pattern on the screen, but now the photons have nothing to bounce against. And so you would have to speculate or assume that somehow the photon turns the corner. Okay, and explain that from a physical point of view, and you can't. That's why they don't have an answer for that question today. Under the rope model, very simple. Every atom is from the source is already connected to every atom of the needle before you turn on the light. And all you did by turning on the light is just increase the frequency, meaning you shorten the lengths, bring down the ropes, in other words, the atoms really, because they receive this impact, right? They pump at a different speed. Now that pumping sends the rope that's connected to your eye receives a frequency that comes within the visible range. And that's all that's happening. And then, so what happens is that frequency, that length, is transmitted to the atoms on the wall, and those are now pumping at a different speed. They're bum, 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 bum. They're expanding and contracting at almost the speed of light, and sending that frequency to your eye, and that's why you can see it. You can see the fringes. So we have an explanation. It's a mechanical, mechanistic explanation. And that's what mathematical physics doesn't have, even to this day, an explanation for. Okay, another issue related to my subject that I like so much, Neanderthals. The fellow says clothing might not have been required in Africa, but it would have been needed by any furless hominids exposed to cold weather conditions. Okay, he's saying that the Neanderthals in the Arctic region would have had to have worn clothes. They couldn't have survived otherwise. Okay, Neanderthals would have needed clothing of some time to have survived European and Asian winters. Denisovans were closely related to Neanderthals and would have also required clothing to survive. Is this true? Did the Neanderthals wear clothes? That's the bottom line. That's the question. Were they dressed like that guy there, you know, with furs and whatever, or like the monkey on the right? Which monkey is the correct Neanderthal? Will the real Neanderthal please stand up? Okay, let's find out. Here we have it. These are the Neanderthals that Hollywood puts out there, and they dress them all up. And so people get used to these notions, okay? And they say, yeah, we understand that the Neanderthals had to be covered because it was so cold in those days in the Arctic. And so this is what you see every day, and that's what you believe, okay? And so I'm going to modify that a little bit, and here it is, okay? Let me put it over here so that we educate you a little bit. 800,000 years ago, 800,000 years ago, before any Neanderthals were alive on Earth, before they existed, before they came into being, before they evolved, there was a two-legged creature in London, okay, in Happisburgh. 800,000 years ago, there was a two-legged individual, certainly an erectus or an Homo antecessor, one of those, maybe a Heidelberg, I don't care, one of those guys. They were already living in Happisburgh, Arctic weather, hunting mammoths. Just look it up, okay? Not only have they found footprints, they have found bones of liquidated mammoths around a fire. There was some kind of two-legged creature. Did that creature wear clothes? Were clothes invented 800,000 years, almost a million years ago? That's the question for you, okay? And so again, you got to do your research. I'm saying that there were no clothes 800,000 years ago. There were no clothes 500,000 years ago. There were no clothes 300,000 years ago. Clothes were invented from my research, I can tell you that clothes were invented around 35 to 40,000 years ago by humans. People, clans that came from Africa, they drifted into Europe because the Neanderthals were no longer there. That's why they could enter Europe. They entered the Neanderthal kraals, so to speak. They entered their caves. They probably found the Neanderthals' bones there, dead, and they kicked them aside and say, I'm going to live here now. And they say, oh, it's so cold in here, you know, and so they started building clothes. They invented needles. They invented threads. They probably put furs together. As they moved gradually into the Arctic weathers, little by little, they started, you know, weaving clothes or using the skins of animals, which they sewed together somehow. Okay, and so I'm saying that clothes were invented when humans, the only animal that ever invented clothes, entered into Europe around 35 to 40,000 years ago, when the Neanderthals were gone. Neanderthals were furry animals. They were the woolly man. Before then, there were the Heidelbergs. They were the woolly men and also lived in Arctic weathers. Before them, you have the, either take your pick, the Homo erectus or Homo antecessor, whichever one. And they lived in Arctic Europe at least 800,000 years ago. And they had no clothes. Okay, so you figure it out. And then just in case, you know, you have wolves today. They sleep in the snow. And you say, how can that be? Well, have you heard of the polar bear? Does he hide in the snow and say, oh, it's so cold today? No, he sleeps in the snow. Wolves sleep in the snow. The buffalo up there also sleep in the snow. And you say, well, humans can't sleep in the snow. Well, not us. That's our puny humans. You know, we have thin skin. Neanderthal, they had thick skin because they evolved from the Heidelbergs, who evolved from the Homo erectus or the antecessors. So they had already thousands of years of acclimatization to the Arctic weathers. Okay, so yeah, I'm sorry, Neanderthals never wore clothes. They didn't wear sandals to walk in the snow. Oh, it's so cold. No, they put their feet just like a wolf does. Puts his feet directly in the snow and just he's used to it. And you say, how can it be? Please understand that wolves do not wear sandals. They do not wear boots, shoes, anything leather covering their feet. Okay, another fellow says, you say that human extinction is inevitable. Nothing can be done. It is nature, so it was decided from the beginning. Living things at some point cease to exist. Your theory is genetic. No, it ain't, but let's continue. Hope is a humane feeling of confident expectation in the realization, present or future, of what one desires. Desire to live. Also a natural mechanism that apparently contrasts that of planned extinction. Mine is not a planned extinction, and what was the other one? No, not saying that. Was it that it's a genetic theory? He's got it all wrong. Okay, so I want to clarify those two things. It's not genetic, and it's not planned. There's no God out there that says, I'm going to plan the death of humans, or of any animal for that matter, or of plant. No, that's not the way it works. The way it works is that the facts are that periodically all plants, all animals, every single species of plants, every species of animal becomes extinct. I hope that sinks through. Okay? It must come to an end. It comes to an end. Why? Because if it doesn't come to an end, to extinction, because of a mass extinction, and I'm just going to put that one aside, it comes to an end through a background extinction. What's a background extinction? It's the disappearance of one species. One species alone disappears, everyone else doesn't even notice it. Everybody else is doing everything, just continues living as if nothing. One species disappears. How did that one species disappear? How did Mother Nature select that one? Well, it selects all of them. All of them will disappear in the same way unless a mass extinction gets them. How did they disappear? They disappear for two reasons. One is their population pyramid overturns and they lose their genetic diversity after gazillions of years of inbreeding. If you inbreed, you lose your genetic diversity. If you lose your genetic diversity, not because of diseases like the geneticists tell you, if you lose your genetic diversity, you're not going to have children in the end. You're going to stop having children. Your children are going to be retarded, which is what's happening today with humans. We have been inbreeding for 200 to 300,000 years since our species has been on the planet. And what do you think happens after inbreeding for 200, 300,000 years? Well, you have mental problems. You have physical problems. You have children with 6 fingers, you know. I have to put a 6th one because I don't have 6 fingers. That's what happens. You can't have normal children after extensive inbreeding. So that's the problem. It's not that you're liable to catch a disease like the geneticists say. No, it's that 2 or 3 generations down the road, you won't have any normal children. Okay, that's the issue. And so, it's not that it's programmed by God or Mother Nature or Father Universe or the devil. It's that you can't continue inbreeding. That's one issue. The other one is that, you have a population problem. And let me explain that real quickly here, okay? This is the population problem. Here you see the population on Earth. We're almost 8 billion people. Apparently, according to the latest numbers, we're like 7.9 billion people on the planet, okay? Okay, and how much land area is there? Well, there's about 150 million square kilometers. That comes out to around 53 people per square kilometers. That's a lot of room. If you look at, if you look at 1 square kilometer, that's a lot of space, and you can put a lot of people in there. And we're saying that the population on Earth is about 53 per kilometer square. That's low density. So you say, okay, so we have a lot of room on the planet. Forget about 8 billion. We could put 1 trillion people on the planet. 1 trillion people on the planet we could put. Many times as many as we have today. And physically we could fit on the planet. And that's only on the land area. Remember, the water area is like 510 million kilometers squared, and that's about 2.5 times more than what the land area is. So, assuming we could live on the oceans as well, that number 53, we could put a lot more people here on the planet. What's the problem? Here's the problem. Problem is that we're all nucleated in cities. We're not uniformly distributed across the planet. These are the cities with the highest density on the planet, which are big cities. Okay, these are the big cities with the highest density. Okay, and you'll probably see some of your cities there. Mumbai is the #1 in the planet. It's got 14 million people. The last one, which I thought was probably one of the first ones, is Tokyo. But the only reason for that is Tokyo has been expanding size-wise, sideways. And so that's why they're number 50. Otherwise, if you go to Tokyo, it's an anthole. Okay, but here's the issue. What did I say just now? 53 people per kilometer squared. And here we're talking about almost 5,000 people per kilometer square in Tokyo, all the way to about 30,000 in Mumbai. 30,000 people per kilometer square. That's what you see in Mumbai. And these are not the biggest, these are not the most densely populated cities on the planet. These are the, here, let me show you this. Let me get it here. These are the cities that with the most population density on the planet. They're not the largest cities, okay? And they're smaller cities, but they're more densely populated than the big cities. Give me a second here. Get this out of the way. Okay, so these are the most densely populated cities. They're not the biggest cities, and again, you can see the numbers. They're in the thousands per kilometer squared. So what's the issue? The issue is that here is the trend. Where is it here? This is the trend for the whole planet. Okay, this is the growth rate for the entire planet. You can see it's going down to 0, maybe by mid-century, sometime in this century. We're not going to have more people being produced on this planet. We're going down, 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 down since the year 1963. And why is that so? Well, because when you move to the cities, families that move to the cities from the country, they no longer have children. The cities are not a place to have children. No one was going to have 10 children in a family anymore. You can't have 10 children in an apartment anymore. That was okay in the country. Our great-grandmothers, they had 10 children, half of them died. Great, no problem. 5 of them continued. That's no longer going to happen. Women today, many of them don't even want to have children. And those that do have 1 or 2, that's it. And so when you come to the city for social and economic reasons, no one has children. So it's not a question of either traveling outside the earth, saying, oh, I'm going to colonize Mars. Yeah, or the moon. No, we're not going to have children because, as you can see in the graph, we stopped having children, and we're going to have fewer and fewer children as time goes by from now on. Partly because of homosexuality, which is on the rise, I'm saying. They're not going to have too many children or any children at all, okay, most of them. Then you have women today, they don't want to have children. You move to the cities, you change the culture, you change the social environment, you change the economics. You no longer need to maintain your parents. The state does that. You don't have to take care of the children because kindergartners do that. It's the state that takes care of everything. So, people don't have children, and people seem bogged down by children. They see them as anchors. I want to go on vacation. I can't because I got to take care of the children. Or the children don't have vacation from school, so I can't go on vacation. And, people see that, the young people see that and say, oh, I don't think I want to have children yet. I'll have them when I'm, 75 years old. So they postpone. They don't have children. Then they have them when they're old, and that's when the children come out retarded as well. So it all works in the worst possible way. So the issue is we're not going to go out of the solar system because we don't need more space. It's not like we need to expand our population to Mars and later to Pluto and then who knows to Alpha Centauri and to the entire galaxy. We have more than enough space here on Earth for people. We're not producing people right now because everybody is moving to these ant holes called cities. And instead of having 53 people per kilometer square across the Earth, what we have is thousands, 30,000 people in a given city because everybody moves to the city, like in Mumbai. So everybody moves there and everybody lives in this ant hole. And when you're in the ant hole, you don't produce children. That's the situation. And so, yeah, that conduces to a no growth, and it kills the economy because what is the economy? Human economy? It's more profits next year, more sales next year, and less costs. What does that mean? That you need more people to buy your things and fewer workers. You got to cut down on labor because that's cost, and you have to increase your sales. That's revenue. That's our mentality. That's our economic system. And what's happening out there is something different. You have fewer people being born, fewer demand being created for the future. And meanwhile, yeah, the other part is on target. We're producing machines that replace man. So we're having less work, less labor, and fewer customers. That's the situation. Now you run that to the future and tell me where that's going to end. Okay, let's move on to the subject matter today, and that's going to be magnetism. What is magnetism? What in the world is magnetism? Why does a magnet attract another? Here you have it, okay? My two famous clips here, okay? Here it is. You've seen it here for the first time in your life, okay? I'm going to put them closer together, and you can feel the pull there already. Magnetism, attraction, and there you see it again, just in case you missed it. Not close enough. Okay. In fact, I'll hold it here. You'll see it here, okay? I'm not pushing it, okay? It's pulling, okay? And people say, is magnetism a pull? Yeah, it is a pull. Nothing's pushing from the outside. It's the pull from the inside. And mathematicians haven't discovered that in 400 years. So that's unbelievable. Okay, but we start with a couple of issues that were left over from last time because people are not sure about certain things, especially regarding energy, this word called energy, which is going to enter the picture, okay? Because all these words, energy, field, magnetism, they're all related, okay? Okay, so let's go with this issue, and it's called capacity. What is energy? It's capacity. And so you have to define what capacity is. What do you mean by capacity? Okay, so here it is. Let's find out here. Know exactly what capacity is. That's what one fellow asks or says. And he points to a video there, a YouTube video. And you go in there and, well, let me just analyze that first. Yeah, I always wanted to know what capacity is. I've never seen one. Is this what it looks like? That's what energy is in another video from the establishment, okay? So is that what capacity is? Is that what it looks like? Okay, I go to this video that this fellow points to, and this is what I find. The main points, okay? Obviously, the video is a little longer than this, but this is what it says. It says, one of the biggest questions I get asked is about capacity. Aha. Capacity of, in this case, he's talking about a battery, okay? Capacity means the actual quantity of electricity. Quantity of electricity, okay? That you can extract out of a battery. So how do we measure capacity? So he immediately moves into measuring. He hasn't really finished with what quantity of electricity means. And so you're left dangling there like saying, well, what do you mean by quantity of electricity? What is this, like quantity of water or number of apples? What are you talking about? What is quantity of electricity? I mean, here you have a breakdown. You look up the word quantity and it says the property of magnitude, something having magnitude. And you look up magnitude and it says a number characteristic of a quantity. Another one of those famous mathematical circular definitions. Yeah, you learn nothing from the mathematicians because they never, ever defined a single word in their lexicon. Okay? Okay, so we have to go with a common notion of quantity. And you find, you know, like if you want to say a quantity of milk, what do you say? Well, 1 liter. Okay, and that's different than saying 1 pound of butter, for example. And that's totally different than saying 10 apples. In the first case, you're talking about a measurement. In the second case, you're talking about counting. So counting is not the same thing as measuring. And quantity, unfortunately, has not been defined properly, and it could refer to either a measurement or counting. So that's where the problem starts. Okay. Now you can count meters, you can count dreams. If you're counting dreams, what are you going to count? I mean, are you going to say, I'm going to weigh the dreams, or, you know, say how many atoms are in there? No, you say, I had 8 dreams last night. That's how you say it. Okay. Electricity is measured in amps. So electricity, you can't say, well, you had 8 amps, meaning 8 units, 8 objects. No, amps is a measurement. So when you say 3 amps, you're really referring to a measurement. Same with voltage and same with watts for power. You're talking about a measurement, not a, you're not counting, you're measuring. Okay, and you use this measure called amps in the case of electricity, and that's what you're going to use. So what is quantity of electricity? Well, you're saying 3 amps. What is 3 amps? Well, it's something you measure. In this case, it's going to be the flow, allegedly, the flow of charges. That's what they're going to come down to, okay? And are you going to count the charges and say, I had 5 charges? No, you're going to say, I had 5 amps, which is different than saying I had, 5 charges or 5 electron balls, beads, or whatever. So keep this in mind. We're going to look at, units here. Okay, are we going to count units or measure them? And this fellow points me to a site where it shows that electricity is treated as a physical object. You go to this site, and this is what you see. You see a fellow in there, and he says, look, I have this quantity of electricity. And he puts water in a bag and says, assume that's 10,000 watts of electricity. He's going to treat electricity as a bunch of water, as a physical object. He's going to take these weights, which he's going to say, well, imagine that as a battery, and one is a 12-volt battery, and the other one's a 120-volt battery, okay? And he's just going to put these weights on top of these water bags that contain so much water, so much electricity. That's the analogy. And he's going to then pinch them and going to say, look, more water comes out of the one that's got the heavier weight than the one in the weaker weight, and the uh, lighter weight. Okay, so this is the analogy. He's treating electricity as a physical object. He's saying electricity is like water. That's what he's saying. And voltage is like a weight. And if you put a bigger weight on one of them, you're going to get more electricity out of that bag. Okay, so he's treating electricity as a physical object. That's the notion people have, that voltage is some kind of potential difference, in this case, measured by these weights, okay? And electricity is the water that flows because of this difference in potential. And again, that's a wrong notion because, like I said last week, if that were the case, if it has to do with pressure, if it has to do with difference in potential, as they say, one potential higher, the other one lower, then what are we saying? That the electron beads roll down an inclined plane from high to low, and that's the analogy for electricity, that you have the water tank above, the other water tank below, and water flows downwards. We can all understand that because it's gravity. Is that what we're saying electricity is? High to low? Well, that's very simple. You put the terminals in the opposite direction. You put the one that was low, now you put it higher, the other one lower. Will the electrons flow the other direction? And the answer is no. So the analogy is bunk, is nonsense. This analogy, high to low, because that's gravity. That's not electricity. Okay, that's not how electricity works. It doesn't work on high to low difference in potential levels, that notion. It doesn't work that way. So you have to come up with a better analogy for what voltage is, this difference in potential. What do you really mean? And this guy said, I put two weights on these bags of electricity. Yeah, sure. So he's treating electricity as a physical object, when electricity is not. They say it's the flow of electron beads, and last week we showed that it's not. In other words, we argued that the electron bead model doesn't work, first of all, because you cannot imagine the planetary model on which it's based. You cannot imagine why that electron bead rolls around the nucleus without falling to it or flying outside of that system. Why do we have a planetary model of the atom, which has been debunked anyways by the same quantum people? They say that's not the model. So why do they teach that model? Why do they use that even as an analogy if that's not the case? Give me the real model, the super duper quantum model of universities. That's the one I want to see. They don't have one. Even in the universities, they use the planetary model. And the planetary model is bunk, but they use it anyway because they have no other model. And they use the electron as a bead. And yeah, when you use a voltage, when you try to explain voltage, you have to explain it with a bead. And you say all these beads roll down because there's a difference in potential high to low. Is that what electricity is? Are the little beads rolling down an inclined plane? And if we put them in the opposite direction, we show that's not the case. So the analogy is nonsense, and the planetary model of the atom is nonsense. You can't use the electron bead as a model because that model has been debunked. You cannot rationalize it. Okay? So anyone using the bead model, that electricity is the flow of electron beads, is talking nonsense. Okay? Electricity is not the flow of electron beads, because you cannot justify that model, because you cannot justify the planetary model of the atom to begin with. I hope that's clear. Okay, so you got to start there. You got to show me your atom before you talk about electron beads flowing. Okay, that's where we start. Okay, along the same lines, The fellow says, I got attacked for saying photons were light. Poor fellow. I was told this is wrong. Can you clarify? Is the electromagnetic spectrum a total fraud? Okay, and so this is my quick answer. They should not attack you. Okay, whoever did that is a meanie. They should treat you with the respect that you deserve. Okay, you're not wrong. Okay, I'm on record. You say I was told this is wrong. You're not wrong. Okay, I'm on record. The electromagnetic spectrum is not a fraud at all. Okay. Okay, so here's my answer to that, my real answer. Okay. You're not wrong, you're irrational. The photon is not an object. The photon is a concept. Photon is a wave function collapse, whatever that means to you. Okay? Particles cannot explain any phenomenon or property of light, not one. Okay? Particles cannot explain anything about light. So anyone using discrete particles is talking nonsense. Aside from the fact that the so-called particle of quantum mechanics is not a particle. It's not a corpuscle. It's not a speck of dust, a grain of sand. The particle of quantum mechanics is a wave function that collapses. It's a number. Okay? It's a function, an equation. I don't know how else to tell you. Okay? That somehow collapsed, physically collapsed to a point. Is that point a dot? What is it? Is it a so-called photon? Are we talking again about a grain of sand? No, we're talking about a nothing. We're talking about a number that collapsed, whatever that means. Okay? And then you cannot simulate wavelength with discrete particles. Anyone using particles, we call them an idiot, meaning a person with big ideas. He doesn't have normal ideas, he has idiots, and so we call them idiots. Anyways, the spectrum is the graph of different lengths of the electromagnetic rope, and there you see them, okay, at the top. But these people think that it's, I guess, the thickness or the width of a photon, which is a particle. So I don't know how you can simulate wavelength or link length with photons, with photon particles, discrete beads. Do they have different sizes? Is that what these people are proposing? Okay, so yeah, the particle model is bunk. It's nonsense. Anyone proposing particles should be executed, period. Okay, they should not be around anymore. Okay, anyone proposing particles simply is talking nonsense. You cannot explain a single phenomenon of nature, the invisible stuff, intangible stuff, with particles. Okay. Okay, so what is this magnetism thingy? Okay, and here we go to live science, and essentially everybody says the same thing. So I chose one at random. I chose live science. Fellow writes in there, what is magnetism? Okay, what is it? Magnetic fields and magnetic force. Okay, let's see what he has to say. He says, magnetism refers to physical phenomena arising from the force caused by magnets. Yeah, okay. Objects that produce fields, okay, that attract or repel other objects. Fields that attract and repel? What is this field thingy? I wonder. A magnetic field exerts a force on particles in the field due to the Lorentz force that you see there on the right, okay? According to Georgia State University Hyperphysics website, which is where that graph on the, or that picture on the right comes from. Okay, so the guy's just relying, I guess, on authority. He's saying, I just go by what the Georgia State University tells us. Okay, great. The motion of electrically charged particles gives rise to magnetism. Okay, so we have electrically charged particles, and that's what gives rise to magnetism. So what is this Lorentz force? Well, it's just an equation. It's just a description, mathematical description. So as you take the electric force plus the magnetic force, and that's the force, the Lorentz force. Great. We learned a lot. So this force, this is what becomes the field, which is what moves objects around. What is this fieldy thing? Okay. That's what we want to get to the bottom of, because they're going to use this word field to say why a magnet attracts another. They're going to explain magnetism with this word field. That's what you got to keep in mind. So we're going to have to get to the bottom of this word field. Okay, so the fellow says magnetic fields are generated by rotating electric charges. Okay, so we have rotating electric charges. Okay, and what are you talking about? He's talking about electrons that are moving. Again, he's going to think of this as electric beads or electron beads, okay? And he's going to call them electric charges because the electron carries, like we said the other day, it carries 1.6 times 10 to the minus 19 coulombs of charge, okay? And it says electrons all have a property of angular momentum or spin. So these charges, these electron beads, they spin around, okay? And there you see them spinning, okay? Most electrons tend to form pairs in which one of them is spin up and the other is spin down. In this case, their magnetic fields are in opposite directions, so they cancel each other out. However, some atoms contain one or more unpaired electrons, which spin can produce a directional magnetic field, which you see there, okay, the magnetic field. Okay, whatever that is, I tried to illustrate that as best as possible. The direction of their spin determines the direction of the magnetic field. When a significant majority of unpaired electrons are aligned with their spins in the same direction, they combine to produce a magnetic field that is strong. So this is it. You see it. You see why a magnet attracts another. They say the electrons spin apparently in the same direction, and if they spin in the same direction, they create this magnetic field. Each magnet creates this magnetic field, and if they're in the same direction, they kind of sympathize with each other, and they attract each other. That's it. And if you turn them around, obviously the magnetic fields are facing each other and they push each other away. So again, we need to get to the bottom of this magnetic field because this is what they're going to use to explain, magnetism. They're going to explain how a magnet attracts another with these fields. Okay, let me get this out of here. Okay, so there you see it. What is the official version? Is you have on the north or south of the magnet, the electrons that form the atoms that are part of these regions, okay, they spin in the same direction. And so their fields, they create fields that are somehow, I don't know exactly how to visualize it. Again, that's the best I could do, is show you that the fields are out there, these numbers floating around, and they go in the same direction. And somehow those fields produce attraction. But we still don't understand the mechanism, the physical mechanism, especially if the fields are just a bunch of numbers. Okay, and so what is a field? Okay, let's find out. Now, we looked at this the other day. Let's go over this again. A field is a quantity. It's a number, a bunch of numbers actually, represented by a number that has a value for each point in space and time. So we have number. What is a number? Mathematical object. Used to count, measure, and label. Okay, so it's a number. It's an abstraction. Value, any definite mathematical object again, right? Most often a number, meaning another mathematical object that measures and labels. Okay, so it's just, we have abstraction so far, no physical object. Point, it's an exact location. What is space and time? Any mathematical model which fuses the 3 dimensions of space and 1 dimension of time. What is space? It's a fundamental space. And what is time? It's a concept that means the continued sequence of existence. La 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 la. What do we have so far? Nothing. So far, all we have is abstractions. And with this abstraction, they're going to produce a real result in the physical world, which is attraction between 2 tangible magnets. In other words, here we have them, right? Okay, so this is tangible, it's seeable, right? You have 2 magnets there right in the center, the black round things there. and they attract each other. And they're saying that's done by what? A field, which is a number, which is a quantity, which is, a value, which is a point, which is another abstraction, which is space and time, which are concepts. This is done by absolute concepts. That's the explanation. That's the official explanation. So yeah, we have a little bit of problem with all this because they're saying, you're asking for a physical interpretation. How does a magnet attract another? What is magnetism? And they're saying it's an abstraction. It's all caused by these numbers that we have floating around in space that are created by electrons which are spinning. And those electrons are beads that belong to the planetary atom, which is bunk. Bunk according not to Bill Gates, they're bunk according to the establishment. They say, no, that's not our atom. So why do you teach it in high school? Well, we teach it there because it's the simplest way to teach this stuff to kids who are coming up to speed. Well, why don't you teach them the real atom? Well, because the real atom, the one they teach at the university level, is the same atom that they teach at the high school level, which is the planetary model of Niels Bohr, which hasn't changed in over 100 years. We still have the same planetary model in mathematical physics. Okay, so that's the situation. Okay, here to make matters worse, it doesn't stop there with magnetism. We have another issue to resolve. And that's this, that with magnetism, there are north and south poles. This is from a site. They all say the same thing. I just pulled one out. Similar to charge like magnetic poles repel each other, while unlike poles attract. Okay, so we have like poles that repel and unlike poles attract. And we call them north and south poles. We have no idea what's happening at the north or south poles. I guess the way I put it there, the North Pole has Santa Claus, especially now that Christmas came around, I thought about Santa. And the South Pole has the Norwegian flag. If it doesn't have the Norwegian flag on it, you have to doubt whether it's the South Pole. And you say, well, why the Norwegian flag? Well, that's because Roald Amundsen, he's the guy, I think it was 1912. He's the guy who discovered the South Pole, just like Columbus discovered America. He's the guy who got there first, in front of Robert Scott, who died in his attempt to reach the South Pole. He reached it a little later. Started earlier, but reached there later. And Roald Amundsen beat him because he went there with these huskies, dogs who were used to the cold. The other guy brought horses and tractors and who knows what, spent a lot of money and died in the effort. So yeah, if you don't see the Norwegian flag, you don't know if it's the South Pole, okay? Let's make that clear. And the North Pole is the one that's got Santa in it. That's all we know about the North and South Pole. What is this north-south, positive, negative? What do those mean physically? What is the physical meaning of these terms? Okay? Now, Mother Nature understands something else, and it's known as clockwise and counterclockwise. And here you have the mechanism. This is a mechanism, okay? It's not for you to believe, it's for you to understand. Okay, and what we're saying is that when a magnet has when two magnets have opposite polarities, so they attract each other, and when they have similar ones, they repel each other. Why? Well, you can see it here. If they have opposite polarities, their threads are swinging in the same direction. And if you turn them sideways, again, they're swinging in the same direction. Only when you switch them 180 degrees do they repel each other, because now the threads swing in opposite directions. Very simple mechanism. A kindergartner can understand this. The assumption is that all atoms are swinging, which are aligned in those magnets, are swinging the threads in a given direction. That's all. That's the only assumption you have to make. And those lines of force that what's his name? Michael Faraday discovered. Those lines of force are those threads that are swinging around. So what's happening is the iron filings align along those lines of force. Okay, and so that ends the notion of magnetism. Okay, let's get on with the questions people asked last time around and comments people made. Here's the one. Fellow says, what novel predictions can you make from your theory? Any novel observations as well? Uh, what can we say? You know, this guy thinks science is about astrology or gawking. You confuse astrology and palm reading with science. That's your problem. Okay, you're asking a question that's irrational. We don't do predictions in science. We don't do observations. Okay, we do not prophecy. We do not gawk. Okay, that's not part of science. And you know, experiments, doing an experiments and observing what happened. You know, that's not science. Imagine you go to the lab, like in high school they do that a lot. They do that also in college. You go to a lab, chemistry lab, and they pour in a flask or a test tube. They put some red liquid, and you see it there. Okay, and now they pour some grains of whatever, and it turns blue. So you did an experiment. You observed. Okay, you did both those things. Did you do science? I mean, what are you going to tell the crowd? You're going to say, oh, I've got this red liquid, I turned it into blue, and I turned the blue liquid into red, and here's the experiment, and I hope you observe it. Is that science? Or is science explaining why, how that red liquid turned into blue and vice versa? Is that science, or is just running the experiment and observing and not understanding how that happened? Is that science? Which one is science? So no, observation and experiments have nothing to do with science. Neither is prediction. So what are you going to do next? You're going to say, hey, watch closely. I'm going to make a prediction. I'm going to throw these little grains, this little stuff inside the red liquid, and I'm going to turn it into blue. Why? Because you did it in the lab, several times. You know that's what's going to happen. So you say, I can predict. I know. What do you know? Well, I know the red liquid's going to turn into blue. And everybody says, well, see, prove it. And the guy does it and proves it. Oh, he did magic. He's a scientist. And he did it in so much time, what, a few seconds? He can even put that down. He say, it happens in 3 seconds. Is that science? Or is science explaining the mechanism of how the red liquid turned into blue, why it turned into blue? There's a difference. Science is the second one, is explaining. But observing, doing an experiment, observing and making predictions because you saw the effect many times, that's not science. That's gawking. Okay, so don't ask us to gawk. Okay, you can continue gawking if you want. Okay, another person asks. He says, I'm confused by your position on relativity. Okay, you say that the theory of relativity is correct. No, I don't. You say that the speed of light is indeed constant. Yes, I do. On the other hand, you goof about time dilation, space contraction, space-time curvature. Yeah. Okay, given the theory of relativity, the curvature of space-time and the warping of space and time are necessary correlates of the constant speed of light. How do you square the seeming contradiction? Well, this fellow doesn't understand what the theory of relativity says. That's the issue. What is a theory? Is a theory a description, which is what this fellow is describing in the last couple paragraphs there, or sentences? No, a theory is an explanation. Let's get that straight. We're not concerned about the math. We're not concerned about the descriptions. We want to understand what the theory is, what the mechanism is of gravity, and for that you need physical objects. What's the problem with general relativity? There are no objects in relativity. That's the problem. Okay? There's no sun or earth. There's no moon. There's no Jupiter, no Pluto. There are masses. They don't talk about objects, they talk about masses. That's the first one you got to understand. The second one is they talk about space and time. And they say, we have this mass, and it sits on space time because they fuse these two concepts together. So we have the concept mass sitting on the concept space time. And you say, what is space time? Well, don't even try to imagine it because it's four-dimensional, so it's unimaginable. Yeah, any concept is unimaginable. You cannot make an image of four-dimensional space-time of any concept. You cannot even make an image of mass, energy, field, time, force. All those concepts you cannot make an image of. You cannot picture them. You cannot turn them into physical objects. So these people are talking about abstractions, and that's how they're going to explain the mechanism of gravity. That's the physical interpretation they're going to give you. And so, yeah, here we have the problem. Okay, you can see it here. Relativity is not correct. It's irrational. Okay, so it's not an issue that it's correct. It's that it's irrational. Unimaginable 4D spacetime is irrational. Okay, and why is it irrational? Because there is no physical object called space-time. There's no physical object that is four-dimensional, okay? And time is a concept. So to say four-dimensional time, or that time is one-dimensional, or that time is a dimension or has dimension, that's irrational. Time is not a dimension, okay? Time is a number line that the mathematicians use. Okay, and even in the number line, it has no direction, but they put an arrow at the end of it. So time is completely screwed up. Time is simply a number line. That's all it is. Number lines don't have direction. Okay, so that's the problem there. But then we have little c. Yeah, it's a constant. Travels at 300,000 kilometers per second, more or less. Okay, but little c is not a theory. Okay, there is no theory called 300,000 kilometers per second. So the fact that light travels at a constant speed is irrelevant. You can say it's an assumption necessary to move on to the theory, to explain something with that speed or with that constancy of that speed. Why is it constant? That's where the theory comes in. That's where the explanation comes in. So theory is, according to relativity, is gravity is warped space-time. That's what the theory of relativity says. And there you see it at the bottom. They say that the Earth doesn't leave the solar system because time is a wall, a warped wall of time, right? That comes up against the skin of the Earth. Because that's the explanation they give you for why the Earth doesn't fly out of the solar system. That it's like a little ball on a roulette. It just goes around and around because it's going against the wall created by the warpage of space-time created by the sun. The sun weighs down space-time, creates this depression, and then the Earth has no way of leaving the depression because it runs up against the wall. It rolls up around the wall. What is the wall made out of? That warped wall, that's warped time. That's the physical interpretation that general relativity gives. People don't like to hear it. They say, no, that's not what relativity says. Yes, that is what relativity says. I'm sorry to tell you. Give me the physical interpretation of general relativity. Otherwise. Okay, and the theory, Earth does not exit solar system because time is warped. That's what they say. You don't like it, you say that's wrong, that's not what relativity says. Tell me what it does say. Let's find out what it, in other words, I want the physical interpretation of gravity. The physical interpretation. Don't give me any numbers, don't give me any equations. I don't want to hear that. I want objects. I want to know why the Earth doesn't fly out of the solar system. And give me a physical interpretation. What physical object prevents the Earth from flying out of the solar system? And relativity says there's a warp wall of space-time. In other words, I don't care about the space part because people get confused about whether space is a physical object or not. It's easier to deal with warped time. If time is warped, you got a problem. You got a mental problem because time is a concept. You can't say that time is warped like a banana, that a second is warped like a banana. And that's what relativity is insinuating, more than insinuating. That is the theory for why the Earth doesn't leave the solar system. Okay? So yeah, I'm going to fight that to the end. So you better get the correct theory and explain it in luxury of detail. Okay? If you think that that's not what relativity says. Okay, another issue. Fellow says object, that which you can imagine or draw. He's got all these definitions, okay, that he put out there. Concept, a derogatory form used to degrade alternate hypothesis. Love that one. So we use the word concept to insult people, to to kill their theories. But then he says object and concept are synonyms. Now that I don't understand. An object is that which you can imagine or draw. And again, we have problems there because he introduces you, meaning a person, a human, and that's already an object. So an object requires another object to be able to define. And then you got to draw it, which is a verb, and verbs come after objects. First, you have to have an object in order to have motion. And so verbs always have to be defined after defining the word object in physics. But that's not the problem. The bigger problem is that he says it's a synonym of concept. And what is concept? The derogatory way of degrading alternate hypotheses. So I guess the poor fellow must be very frustrated. Okay, anyways, universe, a set of objects that have physical presence with each other. No mention of space. It's just that says that deals with objects. I guess the universe is just the objects, no space in there. No, universe is objects and space. That's what the word universe means. Okay, at least in rational science, and essentially that's what everybody out there also believes the word universe means. We just don't pay attention to the word universe because it's a concept. First of all, there's no physical object called universe because it includes both the objects, meaning primarily the stars, planets, and asteroids, etc., all the atoms, gases, and space. That's it. That's these two groups, matter and space. That's what forms the word universe. And this person says it's just what? The set of objects. Okay, of course he's got irrational definitions. He's got the wrong foundations for any theory that he founds upon, places upon them. Okay, motion, two or more locations of an object. What is time? The same thing, to have more than one location. So for him, time and motion are synonyms. Yeah, all the irrational definitions. And then he says, rational, a religious term used to label notions Bill supports. No, we have a definition for the word rational. We defined that several times, okay? And the main one there is that if you reify objects, if you turn a concept into an object, that is primarily the number one criteria for what is irrational. There are a couple others, undefined words or words that are used inconsistently, okay? And that the theory doesn't follow from the hypothesis, from the assumptions. I give the example that the prosecutor presents a gun and then his theory has to do about poisoning, the person who died. One doesn't follow from the what he presented as Exhibit 1, that sort of thing. So there are different criteria for what is irrational. We have it very clear for physics, okay, and the main one is, again, turning concepts into objects, which is what mathematical physics has done for the last 400 years. Field, force, wave, ether, all these concepts have been turned into physical objects. That's where the problem is. Okay, another issue, fellow says, so when you say that every atom is connected to every other atom, do you mean that any single atom is directly connected to every atom in the universe? Yes, exactly. You got it right. That's a large amount of ropes coming out of a single atom, equal to the number of atoms that there are, minus one to be exact. Yeah? Not sure if that's what you mean. Can you go into this some more? Yeah, you said it all correctly. I verify, I confirm everything that you just said. Okay? One atom is connected to every atom in the universe, in our universe. There could be a parallel universe. I always give that possibility, meaning that every atom in that other universe is not connected with their ropes to our universe, meaning that we would not be able to see or touch any of those atoms. Maybe touch we would, I don't know. This is again speculation, meaning that if one of those universes came across our universe, you suddenly would have something come through the wall that you can't see or touch. Or at least you can't see, maybe you can touch it but not see it. Okay, but no, the issue here is that we're saying that there's a single thread that underlies all matter and interconnecting ropes in the universe. All atoms are interconnected by ropes. All of it is made by a single thread that weaves all of it, okay, all around the universe. So we're connected to everything physically. And so here it is. Here's the answer, okay? What we have is Mr. Feynman, and he gives you an idea because you have this large amount. And this is what Feynman says. He says the gravitational attraction relative to the electrical repulsion between two electrons is 1 divided by 4 times 10 to the 42nd. Okay, the question is, where does such a large number come from? He could never figure that out. And the answer is, yeah, we have a lot of ropes. Even that number, I'm not sure if you could, put your hand in the fire for that. But yeah, when you're talking about atoms in the room, in this room, we got gazillions of atoms, uncountable. Not to mention the number of atoms that form the solar system, the Earth, the solar system, the galaxy, and the universe. You're talking about lots of atoms. And the first question is, why don't you ask that question in quantum? Why don't you ask that question in general relativity? Nobody asks those questions over there. There are so many particles in the universe. Yeah, even under quantum mechanics, you have gazillions of particles. In fact, you have more than in the rope model. Because under quantum mechanics, under general relativity, space itself is made out of particles. So if you include all those particles of space, and there is more space than matter in the universe, well, I don't know, you figure out how many particles there are in the universe. At least we cut it down a little bit and say, look, space is not made out of particles. It's only matter that's made out of particles, out of atoms, right? And it's all made for a single thread. So the thread only includes matter. It doesn't include space like it does in the religion of quantum mechanics and general relativity. So whenever you say, are there that many atoms? First ask that question of quantum mechanics. See, all these people want to ask these questions about the rope model. They say, how can a rope go through another rope? And they never ask that question of quantum mechanics. How can a particle go through another particle in quantum mechanics? How does energy go through energy? You take two laser pointers, you cross them, cross the lights, and they go right through each other. Nobody asks the question, how can they go through each other? I mean, are those physical entities? You can see them. And I'm sure if you point the laser enough at your hand, you'll probably burn a hole in it if the laser's strong enough. So it's a physical object that's coming out of that laser of some kind. It's got at least it has a physical influence over your hand, which is made out of atoms. And then you take these two lasers and you can cross them right through each other and they don't get deflected or, the particles get scattered or anything. And nobody asks the question. Nobody asks even questions how that can possibly be the case. How can light go through light? Nobody asks that question. But when I say the rope goes through each other, how can the rope go through each other? Well, the rope is light, and we got to explain how light goes through light, so the rope had better go through the rope. And you say, but how can a rope go through another rope? Well, because an object is not that which you can see or touch. An object is that which has shape. Not all objects can be seen. Not all objects can be touched. Period. Okay, so until you understand that, unless you get that under your skin, you're going to be rolling in your sleep all night. Okay, final issue. Fellow says, Bill said, all objects are made of shape and space. Made of shape and space. I don't know what these people think. They understand everything in irrational manners. They have irrational brains. That's what they have. And they understand everything wrong. So they want to reword it, and they reword it wrong. They don't understand what I'm saying. Every object is surrounded by space. Yeah, if you can say surrounded by space, what I'm saying, space serves as a backdrop. That's the best way to put it. But yeah, you could say it's surrounded by space, but space is nothing. There is no surrounding object. Space is nothing, and this guy can't get this through his thick skull. Every atom is contoured, encapsulated by space. Yeah, in other words, what we're saying is space is nothing. Space is that. What does nothing mean? Nothing is that which doesn't have shape. So you can't say space is a thing. Okay, there is no such thing as space. Space is nothing. No thing, nothing, okay? And it serves as the backdrop to anything. In other words, if you have an atom, what contours it, we call that space, that black stuff. And there you see it. God creates an object, okay? And we call it object X. It's got a shape. We don't know what it is. We don't care. It's an object because it has shape. And it's got to have something contouring it. Otherwise, that thing would be an enormous block, an infinite block of whatever, if it didn't have that black stuff all around it. And thanks to that black stuff, which we call space, that thing is limited. It has shape. Even God has shape thanks to that black stuff called space. Without that space, that nothing, that black stuff, God would be an infinite block of whatever you want to call it, X. So space contours every object. Specifically, it contours every atom. Specifically, it contours every rope. Another guy said, if the ropes are so many, there wouldn't be any space. No, hopefully space contours every rope in the universe. For otherwise, you would not even imagine a rope. The rope would be a single block, infinite block of whatever. And so, yeah, space is necessary in order to distinguish objects. So there had better be space, meaning it ain't there because it's nothing. It serves as a backdrop. Space is that which doesn't have shape. We'll see you next time. What is it, on Sunday? And if I don't see you then, Merry Christmas. We'll see you then. Bye-bye.